So, there's a new tool from Google that's promising to completely flip the script on how we build software. Imagine an AI partner that can take a simple idea and, well, just run with it, turning it into a finished product all on its own. It's called Antigravity, and boy, has it kicked up a storm of excitement and some really serious debate. Is this the absolute future of development? Or are we just swinging the door wide open for a brand new kind of security nightmare? Let's get into it.
And this quote from the dev community, it really just nails it. Anti-gravity isn't just another tool to help you write code a little bit faster. No, this is about lifting that mental weight. You know the one, the constant jumping between your code editor, the terminal, the browser, running tests. It's a huge shift in what an AI tool is actually supposed to do for a developer.
All right, so here's what we're going to cover. We're going to look at both sides of this thing. We'll start with the cool stuff, this new era of coding and how anti-gravity gives you what feels like a whole AI development team. We'll actually see one of its agents in action. And then we're going to pivot to the scary part. A zero-click security crisis, the big debate it sparked, and what it all means for the future.
Okay, so what is the big deal here? What makes anti-gravity so different from the AI coding tools we're already using every day? Well, it all comes down to taking this giant leap from an assistant to an agent.
So anti-gravity dropped in late 2025, powered by the Gemini 3 model. And it was built from the ground up to be an AI-native environment. Now, what that really means is that the IDE isn't just for you, the human. It's built for the AI agent itself. The whole point is for the agent to be able to plan out what it's going to do it, and then check its own work, all pretty much on its own.
And this is where it really clicks. The AI assistants we have now, they're reactive. They give you suggestions, they stay put inside your editor, and they wait for you to tell them what to do. But these autonomous agents, they're proactive. They come up with their own multi-step plans. They can leave the editor, open a terminal, run commands, even open a browser to test a web app. And this is the key. They verify their own work.
Okay, so let's dig into how this actually works. You have to think of it less like a single tool and more like an entire AI development team. Let's break down the core components.
So at the heart of it all, you have the agent. And honestly, the best way to think about this is like an AI junior developer. You give it a high-level task, something like build a user profile page, and it has all the tools it needs to just get it done. It can read and write files, run commands, use the browser, the whole shebang.
Now, if the agent is your junior dev, then the agent manager, that's your mission control. It's this high-level dashboard where you, the human, get to be the architect, the team lead. From here, you can spin up multiple agents at once, give them different jobs, and just watch them work in parallel. It's pretty wild. One agent could be fixing bugs in the back end, while another is building a brand new feature for the UI.
And what's so cool is how you can switch between these two ways of working. You've got the editor view, which is that familiar environment where you can get your hands dirty, write code, and review what the agent did. But then you can switch over to the manager view, that big picture mission control to zoom out and manage the entire project.
Okay, but how do you actually trust an AI that's running around your system doing all this stuff? Well, that's where artifacts come in. These are basically reports that the agent creates to prove it did the job right. We're talking implementation plans, code changes, test results, and, get this, even screen recordings of the agent using the app. It totally solves that black box problem and makes the whole process transparent.
All right, theory is one thing, but what does this actually look like in the real world? Let's walk through an agent taking a simple idea and turning it into a real working app.
So picture this. You give it a super simple prompt. Build me a to-do list web app. The agent doesn't just start spitting out code. First, it creates a plan, an artifact you can check. Then it writes the HTML, the CSS, the Python. But it doesn't stop there. It actually starts a local web server, opens a browser, and starts using the app it just built, adding to-do items, checking them off, all to make sure it works. And as the final proof, it hands you a screen recording of the successful test.
And you're not the only one who'd be blown away by that. This quote from the YouTuber Vlad just captures that jaw-on-the-floor moment perfectly. He's just watching as the AI is clicking around his screen, testing the app it just created moments before. I mean, that's insane. It's a real glimpse of something totally new.
Okay, so far this all sounds amazing, right? A total game changer. But with this kind of power, this incredible autonomy, comes a really, really scary new kind of risk. A danger hiding right out in the open that security researchers found almost immediately. See, the whole system is built on one simple idea: trust. You trust the agent to follow your instructions and get the job done. But what happens if that very trust can be turned into a weapon against you?
This is where we get into something called indirect prompt injection. And it's sneaky. This isn't about you telling the AI to do something bad. It's about an attacker hiding instructions inside a piece of data, say a code file on GitHub, that your agent is going to read later. The agent finds these hidden commands and, not knowing any better, just follows them like they were legitimate orders from the system.
So here's how the heist goes down, step by step. First, the bait. You ask your agent to use some innocent-looking open-source library, but hidden in that code are secret commands. The agent finds them, and because of how they're formatted, thinks they're top-priority system instructions. That's the betrayal. It then carries out the heist. It starts snooping around for your secret files, API keys, passwords, copies them, and then, for the escape, it sends them off to an attacker server, disguised as a totally harmless network request.
And the craziest part? This isn't technically a bug. It's an attacker using a feature against you. The system that was exploited was designed to give the AI important, non-negotiable instructions from the system itself. The critical flaw is that the agent just can't tell the difference between a real system message and a fake one that an attacker planted in some random file it downloaded.
So when security researchers found this, it immediately kicked off this huge, fundamental disagreement between them and Google about what to do.
And this right here, this is the heart of the whole debate. On one side, you have Google, who has basically said this is expected behavior. They argue it's a known risk with these kinds of powerful tools and that it's up to you, the developer, to check the code you're using. But on the other side, the security community is shouting that this is a critical flaw. They say that an AI agent must be able to figure out where its instructions are coming from, and that automation like this should never, ever be allowed to just bypass basic security.
So where does that leave us? We've got this incredible promise on one hand and this terrifying new danger on the other. What does this all mean for the future of how we build things?
All right, let's just quickly recap the big ideas here. First, there's no question autonomous agents are a massive productivity boost. Their ability to plan, act, and verify their work is a complete game changer. But that exact same autonomy opens up a brand new, super stealthy way for attackers to get in, and that has kicked off this huge debate over who's responsible for security. It all comes down to a principle that's as old as time, but has suddenly never been more important. Trust, but verify.
Look, tools like Antigravity are offering us a deal. They'll take the wheel, handle the tedious and frustrating parts of our jobs, and let us focus on the big, creative ideas. All we have to do is give them the keys to our entire system. This attack shows us that giving up that control has some serious consequences. And it leaves us with one massive question. As we build these amazingly powerful AI copilots, are we really ready to hand over the keys?